This one, right?
Yeah.
Okay, it says the figure is constructed from 11 line segments, each of which has two length 2. The area of pentagon ABCDE can be written as this for M and N considerations. Okay. So let's write all the lengths that we know. This is 2, this is 2, 2, 2, 2. All are equal, right?
Yeah.
2, 2. This one is also 2, this one is 2, and this one is 2 as well. Okay, now, for example, we can draw this one and connect this one. Okay, so let's first work on some angles. What's this angle equal to?
60.
Exactly, because it's an equilateral triangle, right?
Yeah.
So we can consider here, let's write it as alpha. This one is 60 minus alpha, right?
Yeah.
Similarly, this one is 60 minus alpha, right?
Okay.
What's this angle equal to?
60.
What about this one?
60.
Yeah, so similarly, this one is also 60, 60, 60. Oh, no, this one is not necessarily 60 and 60, right?
Yeah.
Okay, so for example, look, we can easily calculate this area because it's an equilateral triangle with side length 2. We can easily find this one, we can easily find this one, find this one. But we should split it into some parts to cover the pentagon completely, right?
Yeah.
Okay, so how can we cover it? You should consider which triangles. For example, here we can calculate this part, right? This rhombus, right?
Oh, yeah. Okay.
Similarly, we can also calculate this one, right? But the
Yeah.
problem is this part and some other parts that we've not calculated, right?
Yeah.
But for example, look, we can see it like two rhombus that have a common point A, right? For example, like this one and this one that we rotate them to go through each other, right?
Okay.
Okay, so for example, can we consider this one to find, for example, this angle? What can we say? We found some angles, right? And we know this one
Yeah.
is 60, this one is 60. Let's call this one FGH. What's the area of ABF equal to?
√3.
Why?
Because of it's an equilateral triangle, and I just used the formula
Yes,
s squared
it's
√3 over 4.
A squared root 3 over 4, right?
Yeah.
So it's root 3. So each of these things are root 3.
Yeah.
And okay, so look on. We rotate these two such that the distance between these 2 points be 2, right?
Okay.
So let's consider triangle ACD, okay? This approach is good. So let's consider AC. And we can consider this one, this one, this one, this one. So I split it into 3 triangles like this, okay? So let's calculate the area of ABC first. It's not hard at all. Try this area ABC.
Oh, it's just √3.
It's root 3. Why?
Because it's like if you take 1/2 of the equilateral triangle,
Ah, yes, you can use like this,
and then
or we
put it
can say
together.
1/2 times this side times this side times sine of 120, right?
Oh, yeah.
Do you know this formula for the area of a triangle?
Um, I don't know that much trig. Only what you've taught me so far.
Let me tell you. So look here, when you have triangle ABC, the area, one formula is this, the area of ABC is 1/2 times, let's call this length BC, 1/2 times BC sine A. Okay? Have you
Okay.
seen this formula before?
No.
Okay, and what's the relationship between sine 180 minus alpha and sine alpha?
Sine of 180 minus alpha is equal to negative sine of alpha.
They are equal. Because look, when we had this, it is alpha, it is 180 minus alpha. Sine was y coordinate, their y coordinates are equal. Okay?
Oh, okay.
So if you use this, sine 120 equals sine what?
Oh, sine 60.
And sine 60 is what?
Root 3.
Root 3 over 2, okay?
Okay.
Now, if you use sine 120 root 3 over 2, so for this triangle, I say 1/2 times 2 times 2 times sine 120. Sine 120 sine 60 is root 3 over 2. So we can cancel
Okay.
these 2's. So it's 2 times root 3 over 2, which is root 3, okay?
Yeah.
What's the area of AED equal to?
It's also root 3.
Good job. So if you calculate area of ACD, the problem will be solved, right?
Yeah.
So try it first on your own.
I got root 11.
Root 11, why?
Because if you take side AC, that's just 2 root 3 because it's two altitudes of the equilateral
Find what?
triangle.
Find what?
AC.
Sine is an angle. AC is a side.
No, I'm saying finding C.
Finding C, you said?
AC, finding AC.
Ah, yes, we can find AC and then AD. And then you try to find this sine?
No, then I just found the altitude and then did base times height over 2.
Okay, okay. Hey, what's AC equal to?
AC is just 2 root 3 because it's 2 times the altitudes of the
Exactly. What about
triangles.
AD?
It's also 2 root 3 because it's isosceles.
Yes, then what?
And then CD is 2, so then that means that the altitude uh of the triangle ACD is root 11 from Pythag.
This is 1, 2 root, right?
Yeah,
12, so this one is root 11. So what's the area equal to?
it's just root 11.
Exactly. So what's the final answer equal to?
Um, it's 2 root 3 plus root 11, which is root 12 plus 11, so then it would just be n plus n, which is 23.
Exactly. So the answer is 23. Okay, good. What's here also we could, for example, consider 2, 2 on. We found AC and then we were able to calculate the area, which is 1 times 2 root 3 over 2, which is root 3, right?
Yeah.
Or we can say this one is half of this triangle, half of this triangle, so it would be this triangle. Okay, good job. What's your next question?